Welcome back ECO736 students. This is video 2 for week 4, measuring poverty and inequality. Sorry about the abrupt ending to the last set of slides, but you know we only have 15 minutes free with Screenomatic. So let's see if we can do better with time here. But just to backtrack, that last slide was just to emphasize the differences between money metric approaches to measuring poverty and other more qualitative means of viewing or measuring poverty. Okay, next up, we are going to look at the distribution of per capita expenditure, and we are doing that by looking at this histogram that shows that distribution for South Africa 2011, and this is in per capita expenditures. So to get to per capita, they divide by household size the total expenditure. And another way of looking at the distribution is to look at this kernel density function. What is a kernel density function? It's basically a smooth histogram. That's why they look so similar. Oops, I'm trying to change my slides so that we can go back. There we go. Okay. So if you look at the x-axis, you'll see it's denoted by per capita expenditure in 2,000 Rand. Now, when we have a distribution of data that is highly skewed, like income data, for example, which tends to generally be highly skewed in the population, often we will do a log transformation so that the data can follow a more normal or near normal kind of distribution, so that visually it's just easier to compare different distributions by different subgroups, which we will do at a later stage. So we've taken the exact same SA per capita data for 2011 and we've just transformed it to logs. So you can see the x-axis now says log of per capita expenditure in 2,000 Rand. And so this histogram and kernel density curves. Kernel density curve, again, this is basically just a smooth histogram. It looks very nice and neat, and it really helps with your visual analysis compared to, for example, this distribution with a very long tail, which is not wrong per se to do, and sometimes we do like to look at it in its actual format, but in most labor economics and development economics, we will log the expenditure data. Okay, and this is why, because when we want to compare the distribution of like income, okay, now we're looking at income, no longer expenditure, but when you want to look at the distribution of income or expenditure by different subgroups like race, by gender, or by geotype, for example, it's nice when it's in this form, in a log form. It's just visually easy to see. So what we have on the slide, we've got monthly household income, but it's on log scale, and we've got it for each of the 4 different race groups in the South African context. And here we've just chosen 2 arbitrary monthly household income lines. Let's say this is the upper end or the upper bound, this is the lower bound over here. And if for argument's sake we wanted to make these poverty lines, which is totally arbitrary, we can then compare and we can look at the incidence of poverty by race, depending on who falls, you know, to the left of this line if we're looking at the lower bound, or who falls to the left hand side of the upper bound line. So just looking at this graph, what can you say about household income by race in South Africa? Well, it clearly shows that the income in the white race group, the way it's distributed, there tends to be, it leans more towards higher monthly household incomes when you compare to, for example, the black group, which when you compare to all the races, it's further to the left-hand side, which is the lower end of the income distribution. Okay. The flatter and the wider this density curve is, the more equally the income is distributed. Okay, but we can look at that a bit later on. If I look at this monthly household income line, let's say it's the lower bound poverty line in this example. If I make this a cutoff point and I say everyone who earns less income per month, less than this particular line, we can consider them poor. Let's just compare white and black race groups, since these are the easiest to visually analyze. You can see that there are far more black individuals who fall below this particular line than white individuals. Okay? Even if we look at the upper bound level, it's almost the whole distribution of black population that falls below this particular poverty line compared to white. Still quite a large proportion here of the white race, but it's far more for the black population. Now, one thing that this graph does not account for is the population size for each particular race, because we know in South Africa that the majority of people within our country are black and white people are in the minority. So the next slide over here has taken that into consideration, and you can quickly see how that changes the figure. So now what you're looking at is the scaled income per capita by race. So we have now taken the population size for each race group, white, colored, Indian, and black, into consideration, and we now compare the distribution of the monthly household income. And what do we find? Even though we've controlled for population size, you can still see that the income distribution for the white group, it tends to be more concentrated towards the upper end of the income scale, while for the black group, you can see the concentration is on the lower end of the income scale as well. So that remains. Let's look at our arbitrary lower bound poverty line here in this example. Still, even when controlling for population size, you can see that even compared to all races, the majority of black people still fall below this particular monthly household income scale, or this line, sorry. And far, let's compare to the white population group, far fewer of them would be considered poor by not meeting this cutoff over here. If we look at the upper bound line, you can still see that the majority of the black race, they fall below this particular income line, monthly household income line. Only a few that earn above it. And yes, there's a fair amount of the white population that are also below, but there are far more who are above it. And so this is a common type of analysis that is done when comparing the distribution of incomes or expenditures between different subgroups. Now, next up, we are going to look at measuring poverty at a specific poverty line, and we are going to use the FGT measures, the Foster-Greer-Thorbecke measures. So here we have our generic formula, and over the next few slides it will become differentiated according to the alpha measure over here. So P alpha will be some measure of poverty, where alpha could be 0, 1, or 2, which are the different poverty measures, and depending how alpha changes, this formula will change. N represents total households, Q represents the number of poor households, Z would represent a particular poverty line that is selected in a particular context, and Y represents income. So if I look at this formula once more, when alpha is equal to 0, we will get what we call a head count index measure. When alpha is equal to 1, we are measuring the poverty gap ratio, and when alpha equals 2, we are measuring the poverty severity ratio. So what does the formulae look like when we adjust for different alphas? So when alpha equals 0, your poverty headcount ratio, it gets reduced to this form, where P equals Q over N. P equals the total sum of all poor households over the total amount of households. How did we get from here to there? Basic math. If your alpha is 0, this becomes 1, and then all of that reduces Q. You multiply the 1 by Q there, and you get the sum, and then your denominator is N, so you get Q over N. When alpha equals 1, whatever's in brackets remains to the power of 1 there. So Z minus Y over Z, that basically reduces to Z minus Y. And we take the Z out over here and we bring it into the denominator over here. So you get 1 over NZ is equal to the sum of all the poor households, which is basically how far your income is as a household, how far that is from the poverty line, which is Z. Don't worry about the nitty-gritty. There's an example later which makes everything very clear. For your poverty severity ratio, your alpha is 2. So now whatever's in the bracket here becomes squared. So when we move the Z over here, it's then NZ squared in your denominator. And if your alpha is the infinity sign, we have Rawls measure, which we won't be getting into. So let's get back to our headcount poverty ratio. Okay, also known as your headcount index ratio. This is basically the percentage of poor in the total population, right? So it's the proportion of a country's population that are living below a specified poverty line. Okay, it is advantageous in the sense that it's easy to understand and communicate, but the disadvantage to this particular FGT measure is that it's very sensitive to income changes around the poverty line. So if the poverty line, for example, is $1 a day, and that's what I earn $1 a day. If tomorrow I earn $1.05, I will all of a sudden be considered non-poor. And there isn't much real difference between $1 and $1.05. So this is yeah, it's helpful when you're looking at large changes but in income, but if you're looking at small changes around the poverty line, it doesn't really tell us much, and then this proportion can change quite significantly. And it's insensitive to distribution amongst the poor. So it only tells us what percent of the population is poor, but amongst those poor, it doesn't tell us anything about the degree or the severity of poverty amongst the poor. And we know from the South African context that distribution can be quite large. Okay, it can go from below the poverty line to extremely below the poverty line, but just by looking at your P0 measure, you will have no idea about how wide that distribution is amongst those who are poor. I'm now at 14 minutes. Unfortunately, it looks like there's a lot of talking this week, so many video clips. Let me finish it off here and then start the next video clip, video 3.